Hello, everybody, and welcome to the first episode of Understanding Ultrasound. My name is Marieke Vermeulen, and I'm the Product Support Specialist of Medis Medical Imaging. Today, I would like to show you our strain analysis within our Q-strain echo application. Strain is becoming a variable that is more and more important to study cardiac function. We can study this with echocardiography, which is an imaging tool that is widely available and can be performed at the bedside of a patient. With our software, we can perform speckle tracking, and with the tracking results, we can calculate strain values. We can calculate longitudinal strain, radial strain, and circumferential strain. So now I would like to show you what it looks like within our application.
Our Q-strain echo application is a part of our very robust Medis Suite platform. And this also includes the viewing within Medis Suite. So we have here our view ports in which we can view all our data. And we can also very easily scroll through all the data that we have available. If I want to launch Q-strain echo application, for now, I'm just going to load all the data that I have available. And I'm going to do a right mouse click, and here we can launch Q-strain echo. While launching Q-strain echo, we will need to assign different views to different images. I'd like to show you a strain analysis on a long axis view. So therefore, I want to show you an apical analysis of strain. So first of all, we will need a 4-chamber view. We will need a 3-chamber view. If we hover over, we can also see the preview. And finally, we will also need to have a 2-chamber view. If you have done this selection, you can continue your analysis. The next step is to provide a contour. There are 2 ways you can provide this contour. The first way is to do a manual delineation of the left ventricle like this. So you do a manual delineation by just clicking along the endocardial border. And when you're done, you will end with a right mouse click. If you've done this, you can still make some minor changes to the contour. But we also have a different way implemented. This is a semi-automated approach in which we only require 3 clicks. The 3 clicks are located 2 at the base and 1 in the apex. You need to place them in the exact same order as depicted with this illustration. So 1 at the base, 2 at the base, and 3 in the apex. This will already give you a nice delineation of the left ventricle. There are 2 ways you can adjust this. You can adjust this in an interactive way by changing the red dots. Also, you can change individual points by changing the blue dots in the figure. If you're satisfied, you can continue your analysis, and then the algorithm will determine a delineation for the end diastolic phase, but still you have the option as a user to make some minor changes. If we then continue our analysis, we can see that we are already giving a lot of strain results. If we want to have a full analysis, so that means a completely filled in bullseye plot and also a 3D model, we will need to repeat this process for the 3 and 4-chamber view.
So currently, I am showing you the results of the Q-strain echo application. Today, I would mainly like to focus on the strain results that we can get. The strain are a result of the tracking, and the tracking can very nicely be seen in this visualization over here, depicting the trajectories. On top of that, it's also possible to show a color overlay, but also to show an overlay of the vectors. Another nice visualization tool that is present within the Medis Suite Q-strain echo application is the 3D model. In red, you can see the endocardial border in end systole, and in green, you can see the endocardial border at end diastole. On top of that, you could also play this movie. Then it will show the longitudinal strain as a color overlay over this model, giving you already a nice indication of the strains within this left ventricle. Besides that, we also, of course, reported the average global values depicted over here. But not only the average values, we can also show you the values over a cardiac cycle. In this case, we have the global longitudinal strain and the global circumferential strain, but it is also possible to only have a look at the longitudinal strain. As mentioned, we have these global values, but we can also evaluate them more locally. There are 2 ways we can do this. We can do this within a bullseye plot. This bullseye plot depicts a 17-segment model of the left ventricle, showing in this case the longitudinal strain. So we can have the longitudinal strain for the apex, but also of the different basal segments. If we even want to have more in-depth information of these strain values, we could also go to the time to peak analysis, which is located over here. If we go in there, we can see that we can evaluate the curves, the strain curves of all the different segments individually. So I can deselect them all and, for example, only have a look at comparing the average to the apical region. We can do this also. This is only for the two-chamber view, but here I'm showing you a long axis analysis view. So we can do the same analysis at the three-chamber view or at the four-chamber view, giving you very in-depth information about the strain values for the different views. Thank you all for watching. I hope this video was helpful and see you soon. Bye.